Hello everyone and welcome to the topic of 5G carrier numbering and waveform. So in this we are going to discuss about carrier numbering and waveform. In our last class we have discussed about the frequency bands. Channel raster is a term which defines a set of reference frequencies, and these are basically used to identify the channel position. Here, a global frequency raster, it is defined for all frequencies from 0 to 100 GHz, and it is used to define the set of allowed RF reference frequencies. This RF reference frequencies in the downlink and uplink is designated by the new radio NR-ARFCN, which is absolute radio frequency channel number. Now we can see here the formula for ranges 0 to 3000, 3000 to 24250 and 24250 to this 1 lakh. So we can see here for global raster, the reference and the range or reference frequencies. 5G new radio carrier, it is based on the OFDM waveform. So the waveform like multiplexing technique that is used in this is OFDM. Now the downlink and uplink transmission waveform is conventional OFDM using a cyclic prefix. The uplink can include an additional transform precoding stage. The optional use of transform precoding is typically related to devices with limited uplink budgets, for example the IoT devices. We can see here the transmitter block diagram for this. That there is a transform precoding, subcarrier mapping, inverse Fourier transform and cyclic prefix insertion. So OFDM in new radio utilizes multiple subcarriers. In 5G new radio there are various subcarrier spacing which are defined. Each subcarrier carries the modulator symbol. So noting that the frequency, phase and amplitude do not change during that symbol. So during the depending upon the frequency as well as the duration of the symbol, the number of cycles will change. Here we can see OFDM symbol. These are the subcarrier and amplitude and phase remain constant. So what are its advantages? So its advantages include that wide channels are more resistant to fading and these equalizers are much simpler to implement. This is almost resistance to multipath interference. Due to the long symbols, beamforming at higher frequencies will minimize the multipath issues, and it is ideally suited to MIMO due to the easy matching of signals. It is sensitive to disadvantages include that it is sensitive to frequency errors and phase noise. These are sensitive to Doppler shift which creates the interference. The frequency is a part of the Doppler shift. Higher frequencies suffer more. Now this new radio forces higher frequency to utilize a larger numerology. So pure OFDM creates high PA, peak to average power ratio. Various techniques and codes are used to minimize this. What is this cyclic prefix? It is prefixing of a symbol. Like we are adding a prefix to a symbol with the repetition in the end. This is used to counter the effects of multipath propagation. Now the receiver is configured to discard these samples. For 5G new radio, there is a common cyclic prefix and an extended one. Extended one provides a greater period for multipath protection and it is linked to the larger cell sizes. Extended cyclic prefix also reduces the number of symbols per slot or subframe such that the data rate is reduced. Thank you.